In previous lectures, we've talked about alkenes and how we name those alkenes. You've seen that we could name them cis and trans or E and Z. And now that we've done some more practice, I'd like to remind you of those two. So the first one is when we have two sets of groups in an alkene and we can compare where they are. So if you look at the first example, we look at the alkene, and that alkene has two groups that are the same and they are on the same side. You could also compare the hydrogens because both of them will be on the same side. So these will have my first priority, this will have my second priority, and the same for this one right here, right? So this type of alkene is going to be a cis alkene. On the right side, we have another molecule, and then we have two ethyls that are on opposite sides of the double bond. They are the same group, and also we could compare the two H's. Because the two ethyls are on opposite sides, we say that this molecule is trans. But what happens when we start having alkenes that have three substituents, four substituents that are different? So at that point, what we have to do is to assign priorities. And so if both one priorities are on the same side, then we're going to call this molecule a Z molecule. Or if those two priorities are on opposite sides, then we will call it an E molecule. And that happens when you have tri-substituted, tetra-substituted alkenes. So let's look at one example. Right here, we have an alkene, and the first thing that we're going to do is split it in half. This alkene is tetra-substituted, meaning that it has four substituents that are different from H. So if we first look at the left side, we're going to see that here I have CH3, here I have CH2, CH3. So this first carbon is connected to H, 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 and this first carbon connected directly to the double bond is connected to H, H, right? One H here, one H here, plus C. Because this one right here on the top is connected to a C, this will have the priority 1 and this will have the priority 2. Now let's look on the right side. On the right side, we have carbons directly connected to my alkene. So let's look at the top carbon. The top carbon is connected to H, H, and C right here. And the bottom carbon is connected to carbon, H, H, right? So same thing, H, H, carbon. It's connected to H, H, and a carbon right here. So what that means is that we have to move on. So we move to the next carbon, and the next carbon is the one that I'm pointing with the arrows. So on the top, we have H, H, and Cl, and at the bottom, we have H, H, H. Because the chlorine is heavier than the H, this is going to have my 1, this is going to have my 2, and so the two 1s are on the same side, and this molecule is going to be Z. Now pause the video here and try it before we looked at it. The first thing, we're going to split the double bond in half. And so here we have a carbon connected to the double bond, and here we have a bromine. Bromine is heavier than carbon, so bromine is going to get our 1, and carbon is going to get the 2. So now right here we have a carbon and a carbon. Let's see what those two carbons are connected to. The top one is a triple bond, which means that it's connected to 3 carbons. 1, 2, 3. Each of the CC bonds counts as 1 carbon. And at the bottom, we have carbon that is connected to H, H, right? 1, 2, plus O. Because O is heavier than C, O will get the priority, so this will be my 1 and this will be my 2, making this molecule an E molecule because the 1s are on opposite sides. Let's look at one more. You can pause the video here and try it before I solve it. So right here, I'm going to split it in half. And so if we look at the left side, we have a carbon. That carbon is connected to HHC. And at the bottom, I also have a carbon that is connected to OO, because remember that carbonyl counts as two O's, and then an H. Because of that, the bottom one gets my 1, the top one gets my 2. Now let's look at the right side. So on the right side, I have a carbon and a carbon. The carbon on top is connected to three carbons, so 1, 2, 3, so that's C, C, C. And the bottom one is also connected to three carbons, 1, 2, and 3. 1, 2, and 3. So that means that we have to move on. So we're going to look now at this carbon right here. And this carbon right here. So if we look at the first carbon, that carbon is connected to one hydrogen, but look at it is what it is connected in the back. 1, 2, 3 carbons, right? 1, 2, 3 carbons. We usually don't look bad, but in this case we have to. This one right here, that carbon is connected to 1, 2, 3 hydrogens, right? 1, 2, 3, it's a methyl, but in the back is connected to a C. So even though we usually don't have to look at what is connected in the back, in this case we have to identify this one as my number 1 priority and this one as my number 2 priority, making this molecule an E molecule.